Let's be real for a second. Every single data set you'll ever work with in the real world is messy. It's got gaps, missing pieces, all sorts of unknown values. So what do we do about that? Today, we're going to dive into SQL's really elegant and sometimes wonderfully weird way of handling this exact problem. So let's just start right there with that big question. Forget about code for a minute. Just conceptually, when a piece of information is just gone, how do you even represent that? I mean, this isn't just a tech problem, it's a logic puzzle, and how you decide to solve it has some massive consequences down the road. All right, so here's our game plan. First, we're going to really nail down what the missing data problem is. Then we'll look at SQL's answer, this thing called null. From there, we'll take a trip into the very weird world that nulls create, see how that totally changes how you join tables, and finally, we'll talk about how to keep your data clean right from the start. Okay, so our story kicks off with a super common challenge. Imagine we're building a user database, maybe for a social network. We've got a new user, his name's Nelson, but we don't actually know his age, and we don't have enough info yet to calculate his popularity score. So check out our user table. See, Bart and Lisa, their data is all filled in, nice and neat, but then you get to Nelson. What do we actually put in those cells with the question marks? We can't just leave them blank. A database needs something there. So what's it going to be? You know, the first thought a lot of us have is, well, let's just make something up. For age or popularity, which can't be negative, maybe we could just use -1 as a special code that means we don't know. Seems simple enough, right? Yeah, well, that quick fix, it breaks down fast. The second you try to do any math, like calculating the average popularity score, your calculation is now going to include Nelson's -1, which completely throws off the result. To get the right answer, every single query you write would need an extra little bit of code saying where pop equals -1. It's just so clumsy and super error-prone. Okay, so plan B. What about another approach? For every column, we could add a second column that just tells us if the data in the first one is valid. So you'd have your age column, and right next to it, an age_is_valid column. I mean, it works, but you're literally doubling the number of columns and turning your database design into a total nightmare to manage. So you see the pattern here, right? These makeshift solutions are just messy. They make your code way more complicated. They open the door to huge mistakes in your calculations, and they just bloat your whole database. What we really need is a dedicated, universal concept for unknown that the database itself understands and knows how to handle. And that, my friends, brings us to SQL's official built-in solution. Instead of us having to invent our own rules, SQL gives us this really powerful concept designed for this exact problem, the null. Now, this is so important to get right. Null is not the number 0. It is not an empty piece of text. It's a special marker, a unique placeholder that literally means a value is not known. It's basically the database's way of shrugging its shoulders and saying, hey, I have no idea what's supposed to go here. And just look at how much cleaner our table is now. Instead of confusing question marks or some random magic number, we just use the keyword null. It's clear, it's standard, and it tells anyone who looks at this data exactly what's up. The information is missing. And here's the real magic trick. Because null is a built-in concept, the database's own functions already know how to handle it. When you ask for the average popularity, the database just automatically ignores Nelson's null value. You get the correct answer. Just like that. No extra work. Problem solved. Okay, so null is this super elegant solution, but it also brings in some behaviors that can feel, well, pretty strange if you're used to regular everyday logic. It creates this fascinating little world all its own. Okay, this is where things get really wild. On the right, we've got a simple query to select all users. It works perfectly, just like you'd expect. But look at the query on the left. It seems like it should do the exact same thing. Find all users where pop equals pop. I mean, logically, a value should always equal itself, right? But this query, it doesn't return Nelson. Why? His popularity is null, and that just changes all the rules. So this leads us to the big, mind-bending question of the day. Why isn't an unknown value considered equal to another unknown value? The answer is, we have to think with a different kind of logic. See, in our normal world, things are either true or false. Simple. But SQL plays in a different sandbox. It uses a 3-valued logic system: true, false, and unknown. Any comparison you make that involves a null value,
Even asking if null equals null, it doesn't result in true or false. It results in unknown. Think about it. Is Nelson's unknown age equal to his unknown age? The only truly logical answer is, I don't know. And since the where clause in a query only keeps rows with a condition is definitely true, all those unknown rows just get thrown out. So here's the bottom line, the thing you absolutely have to remember. You can never, ever use the equal sign to find nulls. It will always fail because of that three-valued logic. Instead, SQL gives us a special command just for this. To find rows where a value is missing, you have to use isNull. And to find rows where a value exists, you use isNotNull.
All right, so we've seen how nulls work inside one table, but honestly, their real power comes out when we start connecting different tables together. What happens when you try to join two tables, but the data doesn't line up perfectly?
Okay, picture this. We've got two separate tables. One lists our groups, like the Dead Pudding Society and the United Nuclear Workers. The second table links our users to those groups. But notice, there's nobody listed as a member for the United Nuclear Workers. So how can we make one big list of all the groups and their members, even for the groups that are empty right now?
The tool built for exactly this job is the left outer join. Its entire purpose is to solve this exact problem. It's basically telling the database, hey, give me everything from that first or left table, no matter what. Then try to find matching stuff in the second table. If you find a match, awesome. If you don't find one, just put null in those spots. And boom, here's the result. It's kind of brilliant, right? The Dead Pudding Society is matched up with its member, user 142. But the United Nuclear Workers group, the one with no members, is still on our list. And over in the user ID column, we see our old friend null, perfectly showing us that, hey, there's no matching member here. So far, we've been talking about how to deal with messy data that's already there. But what if we could prevent some of that mess in the first place? A well-designed database can actually help you do that by enforcing certain rules. It's a concept called referential integrity. Let's go back to our users and groups example. What should happen if we try to delete a user who's still in a group? SQL gives you a few choices. The default option is to just reject it. The database basically says, nope, can't do that. A much stricter option is cascade, where if you delete the user, all their group memberships get deleted automatically too. And a third option, set null, brings us right back around. This one deletes the user, but keeps the membership record, just replacing the user's ID with null, leaving an open spot in the group. And that leaves us with this big final thought, one that really sums this whole thing up. The tension between ideas like reject and set null is really a philosophical question. Are you trying to build a fortress of data, a perfectly logical system that says no to the messiness of the real world? Or are you building a flexible system that uses tools like null to embrace that messiness and actually represent it honestly? The right answer? Well, it depends entirely on what you're trying to build.